Okay, so what we're going to be doing today is matrix multiplication, and the first type of matrix multiplication that we're going to be doing is scalar multiplication, and that's where we multiply a matrix by a number. And so here we have a little box. If I want to multiply a matrix by a scalar, C, which is just a number, it's just a fancy word for a number, multiply each element in the matrix by whatever that number is. So if you have a matrix, and then you have a scalar, a number, times that matrix, you're just going to take everything in there and multiply it by that number. So it is pretty easy. So we're going to do a whole problem here at the bottom of the page. There we go. And it says, what is 4a plus 3b? And here's a. So what I'm doing is taking 4 times 2, negative 1, 8, 5, negative 3, 2, plus 3 times negative 1, 0, 0, 3, 5, negative 2. And the first thing I'm going to do out of that is my two instances of scalar multiplication. So when I multiply everything in here by 4, I'm going to get 8, negative 4, 32, 20, negative 12, and 8. Make sense? And over here I'm going to multiply everything by 3. So I'm going to have negative 3, 0, 0, 9, 15, and negative 6. And now I'm going to add those two matrices, which I'm probably going to need a calculator, but we learned how to do this the other day. So 8 minus 3 is going to give us 5. Negative 4 plus 0 is negative 4. 32 plus 0 is 32. 20 plus 9 is 29. Negative 12 plus 15 is 3. And 8 minus 6 is 2. All right? Make sense? That's pretty straightforward, right? All right. So I'm going to skip the one at the bottom of the page just to save some time, give you more time to get your work done in class so you don't have homework, because I know you usually do have homework when you're in here with me. We're going to do solving a problem that happens to have scalars in it. And when we go about doing this, it follows, first of all, the same type of skills that you use. Whoops, let's get this thing organized here. Solving equations, and also the same types of skills that you use solving matrix equations in the last class. So I have 2x plus 3 times this matrix equals this matrix, right? First thing I'm going to do is multiply 3 times this matrix. Does that seem reasonable? So I have 2 times x plus 6, here I am running amok, 9, negative 3, and 12. Fair enough? And what I'm going to do is subtract this matrix from both sides. You remember doing that the other day? Okay. So I'm going to subtract this matrix. And I'm going to get 2x equals 8 minus 6 is 2. 5 minus negative 3 is 8. 11 minus 9 is 2, and 0 minus 12 is negative 12. Now, to get x by itself so that I can solve for this matrix x, I need to get rid of the 2. And the way I get rid of the 2 is actually to multiply by its reciprocal 1/2. Fair enough? Okay, which means I got to do the same thing over here with this guy.
Couldn't you divide by 2?
We're doing scalar multiplication. There is no scalar division. So that's why it is set up as multiplication and not dividing by 2. But you do understand that that's the same thing. Okay, so these guys cancel each other out, and we're going to do your scalar multiplication of 1/2 here, and we're going to get a 1 and a 1 and a 4 and a negative 6. So we've solved this particular matrix equation. At the bottom of the page is where we're going to start working on matrix multiplication. Now, there's a couple of rules about matrix multiplication, and one of those rules is you have to have matrices that have compatible dimensions, okay? And that's really important. So some matrices you can't multiply because their dimensions aren't compatible. And so here's how you can tell. So if matrix A is an m by n matrix, and remember, m is rows, and n equals columns, right? And you are trying to multiply by a matrix B. Matrix B has to have the dimensions n times r. And so you understand your first matrix, whatever they have in columns, you have to have that same number of rows in the second matrix. So in the box that explains matrix multiplication down here, the interesting thing is, would you agree A is a 2 by 2 matrix and B is a 2 by 2 matrix? Would you agree that's true? So this number and this number are both 2's, therefore you're allowed to multiply them. There's a system for doing this, and I'm going to show you, and this would actually be easier on Explain Everything because I can highlight and unhighlight with the eraser, but I can't unhighlight with paper, so it's not going to work. In the end, whatever this dimension and this dimension is the dimensions of your answer. So this actually is interesting. This will equal C, and the dimensions will be m times r. Those will be the dimensions. And here's how you get it. Your first term, this is row 1, column 1, right? Right here. You get this by taking row 1 of this matrix times column 1 of this matrix. So here's what you do. This guy times this guy plus this guy times this guy. Yep, so the only way you're going to get it is to do it. So we have to go about doing it. And so, for example, this over here, this is second row, second column, means take the second row, multiply it by the second column. All right? And that's why they have to have the same inner dimensions, because otherwise they won't match up. So, let's go ahead and do this. All right? And let me tell you something. When you do this, this is not, matrix multiplication is not commutative. If you multiply in a different order, you're going to get a different answer. All right? So here's what we've got. A times B means this. Okay. Let's give ourselves a nice big, this is just a 2 by 2 matrix here. Here's what you're going to do. You're going to take first row times first column. So this is 2 times negative 1 plus 1 times 0. This number times this number plus this number times this number. This number times this number plus this number times this number. You're taking this row and superimposing it on this column and multiplying and adding all your products. So to get our first row but our second column number, we're going to take our first row times the second column. So this is going to be 2 times 3 plus 1 times 4. To get the second row, but the first column, you're going to take the second row times the first column. So this is negative 3 times negative 1 plus 0 times 0. And lastly, to get row 2, column 2, you take row 2 times column 2. So negative 3 times 3 plus 0 times 4. And in the end, you just got to do your calculation. So this is negative 2 plus 0 gives me negative 2. This is 6 plus 4 gives me 10. 3 plus 0 gives me 3. And negative 9 plus 0 gives me negative 9. All right, let's do another one. So B times A means the B comes first and the A comes second. And this is how you'll get to C. You're not going to get the same answer. So negative 1, 3, 0, 4 times 2, 1, negative 3, 0. Okay. Give us a nice big 2 by 2 matrix for our calculation. First row, first column means first row times first column. So this is going to give you negative 1 times 2 plus 3 times negative 3. This is first row, second column means take first row, multiply times second column. So negative 1 times 1 plus 3 times 0. Second row, first column gives you second row, first column answer. So this is 0 times 2 plus 4 times negative 3. And the last one, this is second row, second column. Take the second row times the second column. So this is 0 times 1 plus 4 times 0. And we just need to do our calculation here. We're going to get ourselves an answer. So this is negative 2 plus negative 9 gives me negative 11. Negative 1 plus 0 gives me negative 1. Over here, 0 plus negative 12 gives me negative 12. And 0 plus 0 gives me 0. So you'll notice these don't bear any likeness to each other at all. And that's there isn't any likeness. They're two totally different things. Now, let's go back here for a second to talk about the dimensions when you multiply. I guess instead of R, they used P in their example. If A is an M by N matrix and B is an N by P matrix, then the product matrix is M times P. All right? So here's what you've got. An M times N times P, and these guys have to be the same, is going to give you an M times P matrix. Okay, so you've got to look at your dimensions first, because sometimes you can't even multiply, and you need to know you can't even do it. Don't think it's really hard, you just can't do it. So right here, would you agree, matrix A happens to be 3 rows, 2 columns, right? So this is a 3 by 2. Over here, this is 2 rows, 4 columns. So 2 rows, 4 columns. So do you realize you can multiply these, and when you do, your answer will actually be a 3 by 4 matrix. It'll be huge. Okay? But the way you got to go about doing when you do this, for example, you have this 3 by 4 matrix that you're going to get as an answer. If I want this guy right here, which let's say is row 2, column 2, so they would call this A22. You take row 2 and multiply it by column 2. So 3 times 8 plus 4 times 12 is what would go in there. And that's how you can always, so you don't have to do this in any particular order, because you can reference back what row and what column go together based on what row and what column that spot is over here. All right? Let's go ahead and check out this bottom part, which is just figuring out if you can do this. So would you agree, A right here is what dimensions? I should ask you, what dimensions is this?
3 by 2.
Okay, so this is 3 by 2, and what dimensions is this? 2 by 4. So, could you do A times B?
Yeah.
Yes, you could, because the 2 middle ones will be the same. So this is a big yes, and you'll actually get one that is a 3 by 4 matrix. Now, if you're over here, this is going to give you a 2 by 4 times a 3 by 2. Can you do that?
No.
No, you can't do this. This is a big, fat no. No, you cannot do that, because they're not going to match up.
But the other one does?
Yes, because the other one, here, because the 2 middles don't match up, look what happens. If you take row 1 times column 1, you've got 4 things and 3 things. You can't do that. That won't work.
Okay, so when you take 3 by 2 and 2 by 4, the middle number.
The middle 2 numbers have to be the same. If they're not, you can't do it. And the size of your answer will be the 2 outside numbers. All right? And let's see what else we've got. I'm going to call it quits for there.